Okay, the last video I want to have a look at is question 24 from exercise 9F. In a factory, two machines produce a particular circuit board. The older machine produces 480 boards each day, of which an average of 12% are defective. The newer machine produces 620 boards each day, of which an average of 5% are defective. A board is chosen at random and checked. Let N represent the event that the board comes from a newer machine, and D represent the event that the board is defective. Find the correct two decimal places. We've got the probability of N, probability of it being defective given that it's from machine N. We've got the probability of D and N, D and not N. And we've got this list of probabilities. Now, if you have a bit of a look at the notation that's used, and then you compare that to your textbook, what you'll find is it's actually referring to a lot of the information that is in this table right here. So let's actually just add this in here as well so that we can refer to it as I go along. Let's not get too carried away. Let's stick that down there on my right hand side so I've got the formulas that I need. Alright, so let's start highlighting some of the key information here. We really need to know what N and D are. So that's going to be important, and let's state so N is the new machine. So then by default N dash is the old machine. D is defective, so D dash is not defective. Alright, nothing too sort of amazing there. We have a total of 400 boards from the old machine and 620 boards from the new machine. So we've got a total of 1,100 boards. And then from the new machine, 5% are defective. And from the old machine, 12% are defective. So let's start working through the question, and we'll try and do it the shortest way possible, and I'll try and explain some of these rules as we go along. Okay, so let's start to work out what's happening here. Let's work with the first problem, which is A part 1. And A part 1 says find the probability that I choose a board from the new machine. Well, we know that there's 1,100 boards, and the new machine produces 620 of those 1,100. So I get the probability of 31 on 55 when I simplify that, which is roughly, I did this on my calculator, 0.564. All right, part 2. We want to find out what is the probability that they're defective given that they're from the new machine. Now I could go right back and I could use the formula and use the probability of D and N over the probability of N. I don't need to do this though, because if I read the question carefully, it actually tells me what the probability of them being defective are, given that it comes from the new machine. We know that, wrong one there, not that one, let's undo that. We know that 5% of the new machine boards are defective. So given that it's from the new machine, 5% or 0.5 are defective. So that's where our understanding of what's taking place in the question can be much more useful than having to work through all of the formulas. Okay, part 3. What's the probability that they're defective given that it's from the old machine? Same deal as before. I could use the formula. I don't need to. I just have to be able to interpret the question. 12% from the old machine are defective, so the probability that they're defective given it's the old machine is 0.12. And then we want what is the probability that it is defective and from the new machine. Right, what's the probability that it's defective and from the new machine? This is where we might want to actually use my formula. So I'm going to rub that out and I'm going to give myself a little bit more space. I'm starting to sort of think, I'm not quite sure how this goes together. I want it to be defective and from the new machine. Well, I know the probability of defective given that it's the new machine is equal to the probability of defective and from the new machine divided by the probability that it's from the new machine. So from here, I can rearrange this expression and do the probability of n times by the probability of d given n to equal the probability of d and n. So I'm using the multiplication rule of probability here. Change my pen colour. Why did I know to do that? Really simply, probably just because the question sort of led me through it. It made me find this part first. It made me find this part first. So rather than starting all over again, I can just put those two things together. All right. So now, probability of n, that it comes from the new machine is 0.564 times by the probability that it is defective and from n, which is 0.05. Multiply those two things together and you'll get the probability of it being defective n from machine n. Alright, so I haven't done that multiplication on my calculator. I'll do that now. So 0.564 times 0.05, and we get that being equal to 0.028. Now, how else could I do that? Well, if I didn't use this rule, I can use a tree diagram. I'm going to say, all right, the first thing I want to do is I want to choose that it comes from the new machine, and that's my 31 out of 55. And then the second thing I want to do is choose it to be defective, which was 12% or 12 over 100. So how do I put those two things together to work out what's the probability of both of these happening? So if I follow that path, I need to do 31 on 55 times 12 on 100, and that's exactly what I did over here already. So I'd get the same answer. So I can see it with the tree diagram, or I can use this rule to help me out as I go along. Okay, same process for part 5 of the question, defective and not from the new machine, or defective and from the old machine. So I can jump straight to my formula now. The probability that it is defective and from the old machine is going to be equal to the probability that it's from the old machine times by the probability that it is defective from the old machine. So probability it's from the old machine is 480 out of 1,100 times the probability that it's defective, that was 12%. Type that into my calculator. 480 divided by 1,100 times 0.12, and I get 0.052. Same deal, if I wanted to go to my tree diagram, it would just be a matter of following this path this time. and I haven't got the second part there. So defective, not defective, 12%. And this is 480 over 1,100. Okay, so I can use tree diagrams or I can use my rules. Okay, now it wants part B. Part B in the question says, find the probability that it is defective. Well, if I think about my tree diagrams here, I basically want to take my solution here and take my solution here. Or really, basically, what that is doing is working out the two ways that I could possibly be defective and then adding them together to get the total chance of being defective. So the probability of being defective is, okay, what are the ways I can choose a defective board and then add them together. And that's what our law of total probability is actually doing. It's saying, all right, so what's the probability of being defective? Well, this is being defective coming from the new machine, and this is being defective coming from the old machine, and to work out the total probability of being defective, I have to add them together. And we have done that in part 5 and in part 4 at the beginning of the problem. So the whole chance of being defective, I'm going to write out all of the notation here, is the probability of being defective times by the probability of it being defective given it's from the new machine, plus the probability of being defective times by, and I made a mistake there, probability of coming from the new machine and then being defective times by the probability of coming from the old machine and being defective. And that gives me my 0.028 plus 0.052. Add them together and you get 0.080. So it's a 0.08 chance or an 8% chance that it is defective. Notice I couldn't just add the 12% and the 5% from the beginning. I've got to go into a little bit more depth there. Okay, part C of the question. Hence, find the probability that it is from the new machine given that it's defective. So now part C, find the probability that it's from the new machine given that it's defective. All right, well, we know that's got to be the probability that it's from the new machine and defective divided by the probability that it's defective. So from the new machine and defective, that is 0.05. Remember, I've got to use a decimal, not a percentage, divided by the probability that it's defective, 0.08, which is 518. And that's the end of the question. Hopefully that gives you a bit more of an understanding of how to use these probability rules. And it all really stems back to the tree diagrams and following the different paths on that tree diagram to work out the total probability.